My name is Micah Osborne. I'm the developer of uFrame. I'm part of Invert Game Studios. And before I forget, I'm going to go ahead and tell you that we are going to be giving free copies to everyone that stays for this. So Mike, one of the guys back there, has a USB drive. We pass it around, so if you want it, that may be more exciting once you actually know what it is. So how many of you actually know what uFrame is? Cool. Some of you. Sweet. All right. So I started developing when I was like, wow, feedback. I started developing when I was like 12 years old. And I really got into the whole design and development and the process because I really struggled with finishing something. I was too in particular about how I was doing it rather than focusing on, getting it done. So it really intrigued me. So it took me really about 10 years before I really got it down pat, and definitely learned a lot along the way. And most of my background is mostly in line of business applications. So coming to Unity about 3 or 4 years ago, I've done game development in the past, but when I came to Unity, I really loved it, and I promise you, I stuck with the component model at the beginning. I think it's a great model, but I quickly learned that there was a lot of things along the process that could be extremely optimized and more catered to teams as a whole. So that's more or less what uFrame is and what I'm going to be talking about in a more formal approach. The backstory on uFrame, I just told you all about that. The process of developing a game in uFrame. So we're going to break down each step that the tool really caters to. And it's going to kind of show you how you can eliminate most of the time-consuming problems and design decisions that are faced when most of us develop a game. Because we all face, hundreds of design decisions, some more important than others, and how you can drastically increase the efficiency of your team. We're going to create a simple example showing you the process that we go through and talk about. And we're also going to talk about the vision and future of uFrame as not only an indie tool, but really an enterprise development suite for rapid game development. So, what the heck is MVCVM? So, I really thought that it would be cool to come up with my own acronym, and it just totally didn't work out. It confused the crap out of people, and it really is just MVVM with a little added controller, which is something I found that worked really well in game development, but most people aren't familiar with it. So that's the general idea of. So we're officially calling it MVVM. We're dropping the whole C thing. It is there, but in order to not confuse people, we're changing it to just straight uFrame MVVM. So what exactly is it? It's based on Microsoft's MVVM pattern. It's been used for their WPF and Silverlight technologies. Is anybody familiar with any of those? That's probably why you're here. But yeah, it's based on that pattern. We have slightly modified it to, in our own way, feel like it fits the game engine more, but in general, it is this pattern. It is also tools for rapid development and efficient planning. So there's a lot of things that we do in game development or in the planning stages of development that this tool really caters to, but I found that most people don't really plan. I don't know about anyone else, but I get super excited when I'm sitting around with my team or other people, and we have this big idea for a game, and we just jump right in and we start throwing components on game objects, and we don't really focus on the core concepts of our game. And I never jump up and say, hey, I'm ready to go write this down on a piece of paper. I want to jump right into Unity and start developing. So that's really what this tool does, is allows you to plan. And when you lay everything out in the diagrams, you've fully laid out your entities and elements, it generates this whole MVVM structure for you. So if you aren't very familiar with it, it's really okay, because it does it for you. But it's really pretty awesome when it does, and we'll go a little bit more into that later. So it's made for even the beginner. Really, you don't have to know much to get started. There's literally 2 different spots where you'll be inserting code. It kind of takes care of the rest, because you're really putting in a lot of information when you create these diagrams. So it's also designed to be very portable, not only because it's MVVM, but because it's C#, and we really thought about this when creating the core of uFrame, which is the framework, the underlying what the generated code works with. So we're actually working on things to make it easier to deploy to game servers, even generate web projects, and moving things to, say you've got 100 entities in your game. Well, we can extract that data and actually generate web projects for you. And obviously it works well with Unity, but I'm sure there's probably other projects that you could use this for, as well as testing. Testing's a big thing that I didn't put in here. It's all designed to be very testable, since most of the environment logic is directly on a view, which we'll get into in just a second. So games without uFrame. So when I started developing games without uFrame, just sticking to the component model, there was a lot of things I learned that just really and completely slowed down the process. So, and I also noticed that a lot of the game developers, haven't had a background in design patterns or lack the knowledge on creating a game from start to finish. So I wasn't the only one in this boat. It seems to be kind of like a black box that's very closely guarded in the industry. And we're hoping to kind of open that black box up and say, hey, everyone, this is a great idea, whether you use uFrame or not, that it's very important that we collaborate and build these type of frameworks to streamline this process a little bit more, even for the little guys. So also, it's very difficult to find a good starting place. So, I mean, you've got this big game design and idea, where do you begin? You've got game objects in your scene. Are you just going to throw components here? You get the player running around. Where do you go from there? You've got a million other things to think about, like how are you going to implement networking? How is it going to connect to the web if you need that type of thing? How are we going to connect to Facebook? Most of those things aren't things that you think about up front. You kind of get to them when you get to them. So it's really important to have good structure from the get-go. So this is one of the things that it's very common to get about 80% done with your project and realize that the design that you've laid out absolutely leaves no room for those additional features that you want. I mean, have any of you ever had that problem? I've had it a million times, but not with uFrame. So, it skipped a slide on me. All right, so so now we're going to talk about planning, because uFrame really caters to the idea of planning, but attempts to make it a lot more fun for the user. So I found this picture on Google. I thought it was pretty funny, but it kind of resembles what we do in game development sometimes, or in any development really. We build this big, huge thing, and then it just doesn't work. But all right, decisions. So I like to categorize these as 2 different types of decisions: high impact decisions and low impact decisions. The low impact ones are like moving a function from one class to another, renaming a variable, simple things that aren't going to affect your project. But the high impact decisions are more things that are really you didn't plan for, or you didn't abstract enough, or you just didn't design at all, and you got to add some new feature, and it's going to cause 100 things to break. And we usually do this in Unity with a component model because we'll interconnect components and directly connect them to other components. Then you change one, and it causes your project to, you're going to have regression after that. So moving on. Planning without uFrame. So the key problems with planning is that, creating a good plan is a very time-consuming task. To fully lay out exactly how you're going to do everything, it's going to take way too much time. And also, keeping up with a plan is always an ongoing effort. So you plan, and then you get into it, and you realize, hey, dang it, my plan makes no more sense, so it's basically useless at this point. I made a few changes. We have to redesign. So the higher the fidelity of plan is, the less room that you're given to actually change or leave any room for innovation. And I know as game developers, we're obviously all big fans of innovation, coming up with new ways of doing things. That's kind of what makes it fun for us. And then the lower the fidelity of the plan is, it can leave too much room for unknown problems and potential project regression. So we kind of talked about that a second ago. Also, this is the biggest thing for me, which is planning tends to lower the morale of a project. Just trying to lay everything out, it just isn't as fun as jumping in and getting started. So now we're going to talk about planning with uFrame, and we're going to walk you through each step that the tool kind of follows, so that you can understand basically how it works, and it kind of teaches you the pattern of MVVM in and of its own, because it's designed to follow that iterative development pattern. All right, so scene flow and subsystem planning. So this is kind of the first stage when you're using uFrame, and it's all about just from a very high level defining what are the entities or grouping of entities that are going to be in a game. We like to call them elements. And also the various different scenes and how you're going to structure your scenes. So say in this case we have campaign level 1, campaign level 2. So right here we're defining that each campaign level is going to be in its own separate level rather than having one campaign level that is going to just have some kind of level property that does things different in the same scene. So that's very important to lay out up front. And the subsystems, well, I've only defined a few here, but we could have things like weapons, aircraft, vehicles, however we want to lay them out. This is really just, to get things separated out. You could almost say, each one of these subsystems are for, this developer. Really allows you to separate kind of like what they're going to be working on, or you can do it from more of a high level. This is just what the game is going to contain. And I need some water. All right, so the next step is once you've kind of laid out the basic subsystems, and you can always go back and maneuver things around as you need to, but this is kind of more the general flow. So in this step, element definition planning, this is more or less just where you want to sit around with your friends, or if you're just by yourself, lay out the basic structure of the entities in your game. So if you're familiar with tools like database modeling or POCO entities, you're going to feel right at home. But this isn't just some kind of straight UML designer. It actually takes this information that you fill out here and generates all the code and does it very intelligently. But here you want to, the key idea is to focus purely on the relationships and defining them, as well as the green arrows, which represent inheritance. You can also define that here. So then once you've kind of defined all these, you can collapse these and you've got this entire diagram that you can pass to anyone, and it makes it very easy to determine, what is actually entailed in the game. So if I've been developing a project and there's a new guy I just added onto the project and he knows nothing about the architecture or anything going on, I could pass him this diagram and say, hey, just look. And they're like, oh yeah, I get it. So you can just kind of click around. So the next step, one more thing. You can also move these around as well. I put everything in here just for the sake of clarity in the picture, but like the vehicle and power up and aircraft, you could throw all of those into various different subsystems. So you can kind of like work with things as you need them. So if you're sitting in a room, planning something with this, you might want to just throw everything into one first and then maneuver it around however you're going to segregate it later. So the next step is element focus. So this is probably the biggest step and the most broad step. And this is kind of keen more toward a single developer. If you're going to have multiple developers, you might want to, stick with planning all of your elements at the same time. And when I say element, I really mean entity, but I'm so used to saying elements because that's what we call it. So the key here is to just literally define that single object. And when you double click on the player from the previous step, it jumps right into a brand new diagram where it's just showing you that element. And this is where you're going to define all of the key properties, collections, and commands for that entity. So you have a username here, a health. I basically took this game that I found on Google, and I looked at the screen and saw what he had on the HUD and the player and just defined it. So we've got all these different aspects about him, and then we have the things that, the actions or commands or events that can occur in the scene, and we actually define those here under the commands. So that's usually the first thing you want to do here. And the second thing is, if we look at the picture here, we've got the little actual physical 3D model, and that's one visual representation of this same element, this same data. And we also have the player HUD view, which is going to also represent that same data. It's just visually different. It's more in of a HUD form. And we do this a lot in game development. We take the same data and we display it in many different ways. But usually they can end up coupled together, and that usually ends up creating a lot of problems down the road. So again, the key idea here on the views is these are actually mono behaviors. It generates all these for you. You just throw them on your game objects, and they're ready to go. There's some back-end stuff that works with the element, and it's really good about setting all that up for you. There's plenty of documentation online. We can't literally go into everything in all the details, but it's also a binding framework. So these views really become more reactive. So as a command is invoked, and the views have an easy way to do this, it generates it for you. The role of these commands is to update the information, and when that information changes, it updates any views that bind to it. So for instance, if you look right there under bindings, we have health changed, running speed changed, walking speed changed, state changed. So when these values change and then these methods are called, they're completely decoupled because it's more subscribing. It's basically a .NET event, if you will. So it becomes more reactive. We can take it in, take it out. Makes it very easy to build views or different ways of doing things moving forward. So that's the basic idea of views, is just the whole idea of displaying the same information multiple times. So what does this mean in code as far as uFrame is concerned? So a ViewModel is a single source of truth. I don't know about you guys, but when I first started developing with Unity, I ended up having 100 health properties all over the place, sending data everywhere, and there was no single place where that information was stored. Maybe that was just me being a bad coder. It's also a contract between game logic and visual logic. So this means that if you're working in a team with developers and designers, you can really split things up because that view model is going to be your elements information. And they can both grow along the side without conflicting with each other, because you're both saying, hey, you go work on this end of the data and I'll work on this end. So as long as that contract doesn't change, both sides can grow as they need. So a controller, this is the one thing that we added that really comes from kind of the whole idea of MVC. And it's really just a grouping of command implementations defined on an element. So all those list of commands that we had on the diagram previously, it just basically generates a class where you can go fill in the method. So it's really simple. And then obviously it's a series of views. I already mentioned as it's a component that lives on a game object, and it binds to the view model's data, invokes its commands. So there's a very simple responsibility for each of these. So this is kind of what we mentioned before. The components live on a game object. The views have a single responsibility. The views react to data changing rather than changing the data itself. That's really the key aspect of reactive views, is that nothing inside of Unity is actually controlling the game logic of how your game works. It's more of just reacting and updating the 3D space as things change. Views can also share the same instance of a view model. And this kind of goes back to the idea of a single source of truth. So uFrame kind of manages all these view models living in virtual space out there, and it all works off of identifiers. So when you throw a view on a game object, you have an identifier. You type in the same one on two different game objects. They both subscribe to that same instance of data. So then you can get events on when everything changes. So what do we gain from all this? I know it's a lot of information taken in all at once, but there's really a lot to be gained from it. And some of those key things are, it enforces consistency among each aspect of a game. So these guys aren't developing, something one way. These guys aren't developing in another way. And then you try to meet up and connect, and it just doesn't work. That's another problem I had when developing a game is two developers would split up. And he's like, I'm going to work on the targeting system. I'm going to work on the effects system. And then when we tried to meet those together, it just didn't work. Or we kind of had to hack things, which ultimately left us, with performance penalties. So once you complete an element, you really have to revisit it. So after we've done the whole element focus stage and really focused in on and thought about that element, once we kind of develop it out and since everything's kind of decoupled, we rarely have to revisit and redevelop out unless we're going to add features to that specific thing. And we already talked about the separation between visuals and the game core implementation. Also, the team distribution. So it just makes it very easy for me to split up different aspects and give it to everyone on the team, and they all follow the same consistent model. So it's also a modularized architecture that is loosely coupled. Everything is very highly reusable, and data just simply isn't everywhere. uFrame is really good about hiding. Oh, we'll take questions at the end, or I'll get lost. And so they're very highly reusable, and data isn't everywhere. All right, so now we're going to actually do a demo, and I forgot a mouse. So this is going to be very interesting. If I can get to it. thanks. Saved. So really, uFrame is a very encompassing package, so it's very hard to fit it all in such a short time span. But if you go to our website, invertgamestudios.com, you can read all of the documentation. We have tons of video tutorials. And it is available on the asset store, but you guys all get it for free.
Yeah, I'll pass the USB stick around. This is what it's best to make sure.
All right. All right, so here's the basic graph. I'm sure we're all familiar with graphs with, Playmaker and other tools like that, but uFrame is really nothing like them. It's more of a structure and entity designer rather than it is actually doing any implementation of, moving this object to the left or to the right. So what we're going to do is just do the first step. I'm going to call it Unite Demo. And then I'm just going to add a subsystem here. And for the sake of simplicity, I'm just going to call it core, because that means everything. All right, so I'm just going to hit save and compile here. And what this is going to do is absolutely nothing. It's going to, well, not nothing. It's going to create some files for the scene manager. And basically all the scene manager is it's going to house all of your instances of data. So whenever a game object lives on your scene, it can send a request to this scene manager and get an instance of that data. So, and uFrame is really good about allowing you to create scenes with these. So since all of that is saved and compiled, I can just go straight to create scene. I can go to Unite Demo, and it even creates a scenes folder. And I'm going to call this Unite Demo. All right, so it goes ahead and adds that to your scene so you're ready to go. Again, we won't go into the details of this. It's really pretty simple. We don't have time. All right, so now we're going to go into the second stage, which is planning, and this is going to be the simplest plan for any game ever, really. I'm going to call it Unite Player, and yay, there's our plan. That's it for now. You'd usually go a lot more in depth with this, and it does a lot more than what you'll see, but for simplicity's sake, I'm just going to jump on. So now we're at the element focus stage, and this is really where I want to look in at the Unite player and say, hey, what is this Unite player going to have? So I'm going to say he has a health property, and he also has a state. And I'm going to say he also has a command where he can take damage. And that's basically it. Oops. That's all this guy's going to do for now. And also in this step, we're going to add a new view. So if you're familiar with MVVM, we're basically just creating MVVM. And I'm going to add another view. So we're going to display this information in two different ways. This view right here will be the actual physical character running around. And this second view is going to be the actual HUD display. And I don't have the new Unity GUI, so it will be the old Unity GUI, whatever you want to call it. All right, so now that we've got all of this, I'm just going to hit save and compile again. And just so you can see, it's already generated a controller, our scene manager, scene, view models, which these are just hold the data, and the views, it's already created classes for those. But you really don't even have to look at any of these designer files. This is all maintained for you and generates things as you needed, all the boilerplate code, and leaves these files very empty. Like you can see, this file has no code in it. It's only if you want to extend it. And they kind of all work in that same way. So now we're going to add a view to the scene. And we do this just by right-clicking on it and going to add to scene. So we've got the player view. This is where our little player will live. And I'm actually going to make this easier and just create a cube. Because cubes are easier to work with. Directional light. And then I can also just go add to selection. And this does nothing more than add the component. You can always do it from the add component menu. Oops, I added it to the light. Drag that to the cube. And just for clarity, I'll call it Unite Player View. And then I'm going to add this one to the scene directly. So these are two different things that are going to display that same information. And if I click on Initialize View Model, you can see the information here. I have health and state. But I realized that the health is set as a string, and that's just not accurate. I'm going to make it an integer, and then I'm going to add a new enum and call it Unite Player State. Just link that up. And we'll say he has a state of alive. He can be hurt, or he can be dead. And that looks good. All right, so on our views, right now they're just sitting there doing nothing. So we actually need to tell uFrame what information we want to subscribe to be notified of. And uFrame makes this very simple. It will actually give you a preview of where it's going to insert the code. So if I already had a whole bunch of code here, it would just do it for me. So I'm actually on the player view. I'm just going to subscribe to the state change. And then on the HUD view, I'm just going to subscribe to the health changed. So now I can save that. And now what we're going to do is open up this view and actually do something with it. So it's already got my class here with the state change, the binding we just add. This is all wired and ready to go. So I know in this part of the code, I want to focus on, okay, the state's changed. Now how do I want to visually update the screen to display or represent that this state has changed? So in this case, I'm just going to set a material based on the different states that we just laid out there in the diagram. So if I do public material, we'll say a live material, and we'll create one for each one of those states. Hurt and dead. Then speed code here, or attempt to. So it's going to pass me, in the first parameter of this function, the actual value that it is changed to. And I'm going to say if it's alive, render.material equals alive material. Else, if value equals hurt, we're going to set the material to the hurt material. Duplicate that. And otherwise, we'll set it to the dead material. All right. So as I switch, wait for that to compile. And now that we have our properties here for each one of those materials, we just need to set those, and I made some awesome materials. I've got green, which we'll set to our live. Our red, which we'll set to hurt. And then our black material when he's dead. So now I can run this. And I can set this right here. You can see the property notifications are working. I know this isn't fabulous, but as you start getting a lot of different views with a lot of different bindings, it actually becomes very handy. So now that we've got that wired up, for the same element, we're going to create a simple old GUI label or GUI text, which is awesome. Take up the font size. Let's move him to the left a little bit. Move him up. And this is going to be our health label. This could just as easily be a progress bar or whatever you want to change it to, but for simplicity, I'm just going to make it a label. So let's move right into the HUD view over here. I'm just going to right click on it and do Unite Player HUD view. It's already got my health changed event. I'm just going to type in GUI text. Health label makes sense. Then when the value changes, I'm just going to say health label text equals value. All right. So now in our HUD view, we just need to link up that text label to the property we just created, or the field. And now when we run it, we see the health is at 0. And as I move it around, the binding is being invoked and it's updating the display. So one of the cool new features in 1.4, and it's very common in MVVM, is the idea of dependency properties, or computed properties, if you will. So I can say on this state right here that it is really dependent on health, and then it makes it a computed property. That means that whenever health changes, or whenever state is calculated, that it is really dependent on what the health's value is. So if the health is like greater than 50, the state would be alive. Or if it's less than that, it might be hurt or dead. So that's really what we're going to do now. So since I just set that, I'm going to hit save and compile again. And then I'm just going to right click and open up the controller. And now all we have to do is it gives us a nice little method we can override for computing this new state. So if I type in if health is equal to or greater than 50, then we'll just return the new state, which is alive, else if ViewModel.health is less than or equal to 50, and it's greater than 0, return he's hurt, otherwise he's dead. So I'm being very declarative here, and that's the whole idea of controllers and working with the logic of your game is you want to be very declarative about what's going on. It makes it very easy to understand, and with the property subscriptions, that logic tends to stick in the same spot and not be all over the place. And it makes it very easy to execute this logic outside of Unity as well. So if you're going to have an authoritative game server or something like that, you can actually take this code and execute it anywhere, as well as the view models. So right now, at this point, we probably don't have some kind of HUD to click the button, but that's okay. uFrame makes this somewhat easy. We can click the button here. But there's nothing set up to do that right now, so we can just move this property around. You can see as I move it through the different health stages, it's actually updating the state property now. And this works very efficiently because uFrame does this for you, but it's actually subscribing to the change event of that health value. Then when that updates, it recalculates it. If it's actually different than what it was previously, then it will invoke all of the visual bindings. So it's a very efficient way to have very declarative logic for your game. So now, if we implement the take damage command, just open the controller back up, it's got a method. All I have to do is override it. So take damage, let's say unite player, which is a property for all my data, dot health, minus equals 10. So this is great for developers because we can kind of write a specific rule set or piece of functionality and jump right in and test it before the rest of the game is really put together or any aspect of the HUD is. So if this guy had 100 health, we could hit take damage, and you can see the value is decreasing, moving it into the various different states. So that's a very basic and minimal example. And now we're going to talk about a little bit about the future of this. So not only is this pattern very powerful, but really the whole idea of putting your game into this type of format where you're literally defining everything but the actual literal implementation of the logic of your game, there's a lot we can do with that. And one of the things is networking. We actually have a customer that has already taken this and has made his own custom code generators, which will be doing something similar for the protobuf, and is actually using a authoritative server with protobuf and has implemented some pretty awesome networking stuff. And a lot of that requires some code generation and stuff like that. The next thing is unit test generation. So with all of our information right there, we can take all of your commands, scan all of your prefabs, pull out all the data, and build unit test cases for each and every set of data that you have and for each and every command. So we could potentially generate 10,000 different test cases without you having to do a single thing. Also, the plugin API, it is complete. We're still working on the documentation. There's a lot to document because it's very encompassing, but it will be there very soon. So anything can be extended. You can write your own code generators. You don't really like this pattern, you can definitely tweak it to your own process that you like to take or your team likes to take. And once you do this, it can make your team work very efficiently. Also, you can even have your own custom nodes. So if you wanted to add some kind of, I don't know, state machine. Everybody loves state machines. That's what I found out about Unity. So you could create your own state machine if you wanted to that generates code and works directly with the system. I think this is one of the key things about development and the asset store in general is that there's a million different ideas going around with all the assets. It's easy to want to just go out and buy all these assets, throw them together, and hopefully come up with something. But there's so many different ideas, it's hard to really link them all together in a very efficient manner. So this is a great way to not only build your process, but build great assets. So the other thing is exportable subsystems and elements. So what if you could take, a very large portion of your game and reuse that? It's something that, most indies don't really think about because you're just trying to get done with the game you're on. But a feature like that that's just automatic and built in to your workflow can be very efficient for, growing your company in the long run as well. And it really creates awesome starter kits. And this is one of the things that we're very excited about. We already got some people working on some pretty awesome starter kits with this, where you'll actually get diagrams and fully fledged out games that you can start from. And the cool thing about the diagrams is that you can immediately see the architecture. I've downloaded certain, starter kits before, and I'm like, this isn't how I code. It was very hard to jump in and get going, but with this, you can see it and change it. Everything falls the same way. You learn it once, but if there's 50 starter kits out there that are doing things in a similar manner, it's a lot easier to jump in and get started and actually make use of it. So the last thing is reusable subsystems and menus. So you can, I guess I already talked about that, but the general idea is being able to take your subsystem, export it as a DLL, export it as a Unity package, import it into your other one, and reuse that later on. So that's pretty much it. If there's any questions, I know it's a lot of information at once.
So let's say you have a grid-based game and your character needs to move from one grid space to the other. You click on the space next to it, the animation starts. How do you handle the timing of the view doing something that takes a while versus the model being able to change instantaneously?
There's actually and I can show you that. And we want to go more to a task-based system, so it's not dependent on Unity in itself, because that's kind of the whole idea. But you can, like this, take damage. If I just checked is yield command and hit save and compile. And I'm going to get an error because it's not an I enumerator. So now I just make this an I enumerator. And I'll drop that. I could do your standard yield return new wait for seconds, 10F. And I could repeat the process, or I'll just do this. We'll make it jump to more. Hit save. And that's one of the cool things too, is with the architecture, like every command is actually a I enumerator or a regular command. So making these types of changes where you say, oh, we actually need to implement time with that, it becomes a lot easier. So if I run that and do take damage, it's going to go down 10, and then it's going to wait. How many seconds did I put in there? Did I put too many seconds? Yeah, there we go. So it jumped to 60. So that's kind of how you can kind of implement time. But really, it's mostly to kind of in-house, like, a problem. So when you're thinking of your game as like, these various different properties, you want to kind of encapsulate that in its own and almost feel like you're building a console program where all this, Unity game engine-based stuff isn't there, and you're more focused on the bare essentials of the logic of your game. But you can kind of pick and choose, and you kind of learn as you use the system more, what makes sense. So it's definitely, if you put something somewhere and it doesn't make sense, you'll definitely learn that it doesn't make sense, and tweak, how you learn anything really. Is that it?
How maintainable is the relationship between the diagram and the code generator? It's just now when you change stuff.
Actually, that's the biggest part of the changing is would be, you probably saw the biggest part, that the hardest part to change is changing something like iEnumerator. All of the view models actually generate, if I pull up this view model, it's all partial classes. So it has its own designer files and maintains those on its own. It's only when you need to add something very specific that we don't already handle that you can go in and add additional things to that specific class if you need it.
I saw that you created an enemy here, but what if that enemy already exists from a different framework? What if the property you want to watch is already defined in the script outside?
You want to watch? Well, I mean, this system is more or less built to, kind of start from here. I mean, you can, and there are people that are very successful at integrating this with current projects they have, but it's one of those things where you got to kind of go in and learn it, and because only you know how you've done things, so then you can kind of figure out, how you can work things in. Cool.
With the files it's generating or the designer files, what does that asset look like for the case of merge conflicts and things like that?
The asset file. It's actually, we've started to move towards JSON. So now everything's is JSON, but it's still using an asset file just for the sake of speed. But really what we're looking at doing, and actually this is very much on our roadmap for the next few weeks, is you can take a subsystem or you can take an element and you can kind of export that into its own diagram specifically for the reasons of version control. Almost kind of like a checkout system, if you will.
You mentioned ViewModel. Does that mean that we can use your system and just put something else that we can redistribute on ESS4, for example?
Absolutely, definitely. Not the entire source code or the entire product, but anything that's generated and your diagrams and all that, you can definitely release it on the asset store.
Can you bring up the layered states dependency property?
Yeah.
I couldn't tell if that was a mono behavior or if that was a class.
The dependent. I'm not sure what you're talking about.
The dependency property where you're changing the player's state based on health.
Oh,
Where you're computing that.
yeah, that's actually in the controller. In traditional MVVM, this would be in the ViewModel, but we liked it in the controller simply because it makes it very easy to override and extend without actually changing the type that you're working with. So in different environments, you could have different controllers that might work things a little bit differently.
So can you see a scenario where you have some sort of like mono behavior implementation of this? So can you have those values to be pulled in the editor? So you don't have to hard code like my health is over 50, you can have the designer change that.
Absolutely, and that's one of the things in the future that we want to go to, and I actually already did it, just like messing around one night because I got tired of working on the same thing. So in actually a couple hours, with the way the system's built, I was able to build a very basic state transition system, and we definitely want to lean more toward toward the idea of making this an entirely visual product that follows really a programming design model. So we feel like that's what a lot of the plugins today really don't support, but that design really works well.
Two questions. First one is, couldn't figure out where's the actual model? Is the model what is in the designer itself, or is there?
See, that can be kind of confusing, but the model is the actual properties and state here. Do you mean in code?
Yeah.
So the properties here go straight into the ViewModel, and the commands are actual just properties of an interface called iCommand. So I'll show you.
So there's no model class itself that's like a Pogo class.
Yeah, there is. I'll show you. And it makes it very hard to navigate to it, but. So in the designer file, where it's a partial, it actually generates, you can see these properties here, and these are kind of our internal properties that allow you to subscribe to those values.
So in this case here, that the view model is the model?
Oh, it's not the model. Oh, I see what you mean now. Oh, no, the model is more or less kind of something you implement on your own. We are trying to find a way to to where it makes sense, but we really don't want to drive how you store all of your data. In some cases, it makes sense. We do have serialization methods like read and write, where you can serialize the ViewModel. So in smaller games, it may make sense that your ViewModel actually is the model as well.
Okay, so this whole demo is based around the idea where there is no model in this case, and everything is in the view model.
Pretty much, right now.
And does your system have like an IOC container, or is it something that we should just bring?
Absolutely. No, it comes with an IOC container. Let me show you. If I go to this base class, which is generated for me, it actually, and I only have one element, so it actually looks at the relationships of your diagram and generates properties with the inject attribute. So if I had another controller, it would actually create a property to that controller for me. But there is a bootstrapper. If you go to the scene manager, I go to this class, I've got a property called container, and this is where I could do register instance. And if you're familiar with Microsoft's Unity container, it follows that exact same dependency container.
And can you do things like set up like singleton instances?
Absolutely. Register instance, that's what that does.
And you have an option to make it singleton?
Yes, this right here, if I do has multiple instances, this actually makes it a non-singleton.
It's a singleton by default?
Yeah, singleton by default. It does have some logic where if I add a new element, and then I create a collection to that new element, it'll...
Can you have dependencies not be other, like can you have like I don't know, some other manager or some other services that are not necessarily inside here and just strap it into the bootstrapper?
Absolutely. That's the key idea. So if you have some kind of, if you're using a repository pattern or some kind of other data source like connecting to Facebook, just create a simple interface, bootstrap it there, and then on your controllers or anywhere else, you can just create a property, throw the inject attribute above it, and it'll work just like any other IOC container.
So I thought I saw in one of the designers that you had up, just as you were opening things, transform.position and .rotation listed in the properties.
Oh, okay.
Did I see that right?
Yeah, you did. That's actually for like this two-way properties. Is this what you're talking about?
Well, I just saw it in one of the white boxes under properties, but the real question is, can you actually make those observable? So if I start moving something around in the scene view, can I get notifications that it moved and update my views appropriately?
Yes, you actually can. If I add a property here and go to this, I can make it a vector 2 or vector 3. And then in your update method, you can just consistently set that. I think in Unity 5, they have a transform.hasChange now. So it'll keep it from causing events to subscribed all the time. So it's...
You would have to pull that and update in Unity 4.x. You'd have to pull the position and see if it changed to know if you should fire the...
if you just set the value, because each and every view has a property already set up for you. So, and that property will be generated. So in this case, if I set this to a vector 3 and called it position, I could then in my view, which is my Unite player view here, and just since it's a standard mono behavior, all I'd have to do is implement my update method and check transform hasChange and then update it. Then it would trigger it just like anything else.
Okay.
It's kind of like creating a two-way property, if you will.
I thought I saw one where you actually had transform.position listed, but I might have misread it because it was early on in the presentation and you hadn't actually gone through everything worked yet.
Okay. I'm completely lost. I don't know where.
What is a two-way property?
What is a two-way property? Two-way is, and this is something that we really struggled with the naming, but a two-way property is basically, in the way that it generates it, it allows you to have things that are going to be really real-time, like position, rotation, and things like that, that you don't want to have all these subscriptions to. And it allows you to also define what you would like to be serialized down the wire. So it kind of allows a way for you to transfer data from one end of Unity down into the back end.
So the Unity package that got passed around doesn't actually build a single file called iElement namespace?
Must have been a last minute build. You know what? Forget the USB drive. I'll post a link at invertgamestudios.com/unite. There will be a folder for it. It'll be up for the rest of today. If you want it, just go to that link, and I'll set it up right after this. I actually know what that problem is. It's because I was giving you guys a new build that I actually haven't even released yet. So I'll just give you the old build.
Can you say the link one more time?
Invertgamestudios.com/unite.
Question for you. So we're in one of the diagrams before that you had on the screen, I think there was something that looked like an interface or an interface-like construct. Can you elaborate on that?
Like an inner.
Something that allows to take damage both from the player and from an enemy or something?
Taking damage from the enemy. I'm not entirely sure of the question.
Interface, I mean like the class interface in the C#. Yeah.
Oh yeah, the controller. Is this what you're talking about? Where I have the.
No, it was in one of your diagrams. It was something that the L component was kind of shared between the enemy and the player. They were deriving from it, or was it
Oh, I see what you're saying. Yes. So, say we had a Unite player here, but we wanted to have something at the root and call it character. We can right-click on that and do isTemplate, which basically, in programming terms, is an abstract class. So it makes things abstract. So anything I make the green wire to, now my Unite player derives from character. And it'll get all of its same controller functionality, all the properties from the character element, and I can even derive views off same views that are on the character. What's up?
Yeah. You said it was kind of I think it was on your roadmap, not in yet, but what you're planning on doing is having an API so we can write our own code generators.
Yeah.
Is it also going to be possible to replace or extend the default code generator?
Absolutely. Even down to the method level, and that's one of the things that we ran into when creating our own plugins, was that we wanted to make sure that we could extend what was already there. So we have kind of like what everyone's already familiar with in Unity. If you've done extension development, it's kind of a post processor. So and it uses code dump, so it'll give you a code type declaration, and you can change, extend, modify the way any of it works, or you can completely replace. Say it generates a controller and you want to use just strict MVVM, you can completely take that out or implement a completely different model if you really wanted to, and it makes it very easy. It's already got all the architecture for doing that type of thing if you want.
The uFrame you're giving us today, is it considered a trial or a license?
Actually Unity asked if we would do that, and I'm not really sure what.
Update it off the asset store, because we're not getting it from the asset store, right? So.
Yeah, I think they were going to do it through the asset store, but they didn't really give me much information. They just asked if I could give away free copies on a USB or a URL. So I don't know what I can say there. So currently we don't have anything where you can update on our site. We do want to do that, but there's no way I'm going to really know that, hey, you're a Unite guy. Right on. Cool. What's up?
I was just wondering, have you run into any performance problems because of the overhead of this architecture?
Actually, no, and that's a very common question. It would seem that way, but actually, since everything's more event-based, it's only executing code when it needs to. So it's actually probably more likely that it's going to implement things a lot more efficiently, and because everything follows the standard pattern, it's going to be very consistent and not cause any performance problems, because you don't have to kind of like hack things to make them work. So. Yeah, I know it's kind of confusing because of the whole acronym, and we tried to follow the acronym, but really what the view ends up being is kind of more of a Unity logic type thing. So where you're working with physics and all that kind of stuff, that's where that kind of implementation goes. So anything that is like physics, or it's a mouse click, any kind of user interaction or actual in-game interaction is going to be in the view.
Actually interacts with, like, let's say Unity components should be in view.
Say what?
So whatever you have that interacts with Unity, with user input, with other Unity components, it should be in view.
Absolutely. Only the bare essentials kind of go in the back end to keep the logic a little bit easier maintained in a very logical place for it.
Okay, two questions. The first one, if I made any change to the diagram after I actually started implementing this stuff, will it actually break any code, or will it just simply pass on?
There's some things that it does for you. If I rename an element, it'll actually refactor it for you. It's got some small refactorings. We want to extend that in the future. But if you change something like a command, it's going to, maybe cause an issue if I change the type of it. But that's usually a very simple change because it's just one file. And the more you use it, you'll get used to the very small things that you do have to update. I think most tools like this, usually, we don't want to make it change any of your code. We don't want to go in changing things and trying to modify things unless we built this entire architecture, for parsing C#, would just add a lot of bulk to the product.
Another question is that you are talking about like subsystem export or that kind of stuff. Do you support like things like automatic like namespace handling or kind of stuff?
Namespace is probably the most requested feature that we're working really hard on doing. We started out with not having namespaces because it was my original impression that Unity didn't support them. And then we got a long way down the road and realized we had namespaces now, it's going to break a lot of people. So we're really working on a way to get that in very quickly. So probably in the next 2 weeks to a month, we'll have namespaces working correctly to where it doesn't break anybody. All right. I guess it's over. Thanks, guys. If you have any more questions, just come ask.